This is the Master Brewers Podcast, brought to you by the Master Brewers Association of the Americas, a volunteer organization dedicated to continually improving the products and processes of our membership since 1887.
Let's go!
Master Brewers brings you interviews with the industry's best and brightest in brewing science, technology, and operations.
Calm down, I'm moving too fast.
Support for this podcast and the following messages come from our friends at the Paul Mueller Company and Hopsteiner. Please thank them. This podcast wouldn't be possible without their generous support.
Paul Mueller Company has been manufacturing quality brewing equipment since 1964. Our innovative design and engineering will save you time, labor, and ingredients, sending money back to your bottom line. Learn more about our new mobile hop module at paulmueller.com. This Master Brewers podcast is proudly sponsored by Hopsteiner, a global leader in the hop industry focused on quality, sustainability, and innovation in new hop varieties and hop products. Contact our brewery sales team to provide you with the hop-related tools you need to craft your next great beer. For more information, visit hopsteiner.com.
We noticed that the RQ number, the direct lactic number, was the most telltale sign of how sour the final product was going to be compared to the TA. Really recommend that people do an experiment like this on their own because the growth conditions, the substrate are really going to influence what the final character is going to be from that bacteria.
This week on the show, Tim Lozen joins us from Bells Brewery to talk about their quest to optimize bacteria selection for sour beer production. This work was awarded Best Poster People's Choice at the 2017 Master Brewers Conference. Tim, you did some work comparing the performance of several lactic acid bacteria strains. Give us some background. What's the application? What were you hoping to achieve?
Sure. Well, it started out because we've been running a reactor system here for one of our brands where we use a portion of sour wort in it. And we've been doing that for several years now. Along the way, we've had a lot of trial and error. We've had a lot of inconsistencies. So when we decided to ramp up that brand, we really wanted to pour some money into a new reactor system. And along the way, we wanted to figure out if we were doing things right. So we thought, well, what if we kept everything the same? And maybe some of these inconsistencies might be from the lacto strain itself. Just as we use different strains of yeast to achieve different characteristics, we thought the same might be possible with the lacto that we're using in our reactor system.
Lactic acid bacteria strains can be categorized by how they metabolize glucose. Talk about that.
And sure. So we knew that we were using heterofermentive strains, so strains that don't produce solely lactic acid. So we have heterofermentive and homofermentative strains. Homo will produce solely lactic acid from glucose, and heterofermentive should produce a multitude of things, usually like acetic acid or sometimes ethanol or CO2. And so we knew that we were working with heterofermentative lactobacilli, and therefore we assumed that we were getting a fair amount of flavor out of a lacto on top of just lactic acid. So we wanted to dive in there and see what the differences were in that.
And then there's a third category too, known as facultative heterofermentive. Why don't you explain that?
Sure. So facultative heterofermentive are going to will produce CO2 and other byproducts under specific conditions from specific substrates, compared to facultative, which are going to produce no matter what the growing conditions are, the substrate, they're going to produce different things besides just lactic acid.
And you trialed some strains from each of those three categories, right?
Correct. So we did 8 strains altogether. We did Lactobacillus brevis, KCI, Buchaneri. We did some Delbrueckii subspecies vulgarigus, some Delbrueckii subspecies Delbrueckii, and Delbrueckii subspecies lactis, as well as Plantarum and Rosier.
let's talk about your method. What was the scale? Did you use an existing wort stream? Were these mixed yeast and bacteria fermentations? Give us the lowdown.
So we wanted to keep yeast out of the picture because, again, we were just looking at the flavor profiles and the acidity production of the lacto on its own. We used an existing wort stream that we had. So like I said before, we were using this reactor system for a specific brand that we had. So we just stuck with the wort type for that brand. It was about 50% pale malt and 50% wheat malt. It was unhopped. We boiled it for like 5 to 10 minutes just to kill everything off. So that way we knew we were just working with the single lacto strain. And then for scale wise, we took, we sourced these lactose from different places. And then we'd inoculate that into a 9 mil MRS broth tube. And we let that grow for several days. And then we'd pitch that either in a 0.5 mil or 1 mil into about 900 milliliters of wort. And then we let that brew for 7 days, and then we did our sensory experiment.
All right. Tell us about the criteria you used to judge these strains.
Sure. So we tested them for both titratable acidity as well as a direct lactic method that we called the reflectometer. And that is a little instrument that we bought through EMD Millipore. It was kind of nifty. Some of the preliminary work that we did for this was kind of testing out how we measure success from a lactose strain. So what we're going to measure, things like pH, titratable acidity, and what that's going to tell us. We found that we wanted to use some liquid chromatography to tell us the direct lactic and acetic, but that became pretty time-consuming and expensive. So in searching around, we found a little instrument that essentially is an enzymatic test. We dip these little things into our wort and stick it in a little instrument, and it kind of gives us a direct measurement of lactic acid. So we went with that as well because we were curious on the relationship between direct lactic and titratable acidity. And then we also ran it through our alkalizer for ABV and our GC for BDKs.
Titratable acidity, we could and probably should do an entire episode just on that. But how about giving an overview of what that is and why it matters?
Sure. So titratable acidity is going to be some of essentially all acids that can be measured in your substrate. And so it's really important to us because we're looking at acid-producing bacteria. And so, of course, we want to see how much acid they're producing, and then how much of that is going to translate into the final product. And so it's going to be the sum of any acetic acid or lactic acid that are going to be the two main types of acid that are going to be produced by these bacteria. And so we really wanted to dig in and see how that was important. We did a lot of work originally on what TA method we were going to use, what worked for us, and we ended up on phenolphthalein actually because it was quick and easy, and when we compared it to ASPC Beer 8, the specific method for TA, the numbers were relatively close. They tracked well together, and the phenolphthalein method was just really quick and easy. And so it's something that we do on a daily basis. It doesn't take much time at all. That's and cool. Was giving us numbers that made a lot of sense to us. So we kind of went with it.
All right, great. So you've got TA giving you the all of the acidity, and then you've got the reflectometry, which also known as RQ that you referred to earlier, which is just giving you lactic acid, right?
Correct. Yep. And then we really wanted to see what the relationship between those were going to be, what type of acids were being produced by these bacteria. So like I said, we measure TA on a daily basis just to see what the health of the reactor is and sour wort overall. So that gives us a general idea of how well the lactose is performing. So the TA keeps going up, then we know we're doing good. From our experience, we know what type of gains in TA that we're going to get over time. The RQ number we like a lot because, again, it showed us in the experiment types of lacto were producing mainly lactic acid versus a number of other acids that would push that T up but keep the RQ number down. And then we measure RQ on a weekly basis, and that kind of gives us a good indication. So if we're looking, so we can keep these reactor is going for, I think our record at this point is about a year and a few months. But it's not uncommon for us to go 8 months at a time of refilling these things and just keeping these things going. So the RQ is a good method. If the RQ stays relatively the same, but the TA keeps going up, now we know that either the lactose is not performing how it usually does, or maybe something else got in there that's making some other acids. So that's generally a good time to turn that thing around. The RQ is also a great measurement of the direct lactic, is a great measurement of how sour the final beer is going to end up. So that's something we noticed, because you can have an extremely high TA. We've seen TAs of 1.5%, and then or two, even up to like 2.5%. And then we taste the resulting beer that we make from that, and it just doesn't have that much punch to it compared to some reactor wort that might only be 1.5% on the TA scale, but a much higher RQ number, and then that beer will be much sourer than the 2% TA number was, have a lot more lactic punch to it. So we like the RQ because it gives us a nice number of a good indicator of how sour that final product is going to be. And then if we want to talk about consistency, we could also take that number and then plug it into a formula and figure out the ratio of titratable and direct lactic that we want in the final product. So if we want, something that's not incredibly sour but has a nice kick to it, then we could do the math there and figure out exactly how much sour wort to add into a wort stream to get where we want to be.
Okay. In a minute, we'll get on to the 8 sensory attributes you use. But before that, you mentioned that you also are tracking pH as one of the parameters you evaluated here. What do you consider as ideal for pH in this type of situation?
I think it really depends on your application. The brand that we use this in isn't particularly sour, and so we weren't terribly interested in getting the pH as low as we could at the end. I could tell you that the starting pH for these lactose was somewhere around 6. Our wheat worts tend to be a little higher, so around 5, 8, or 6. And that we found has been a good starting point for these bacteria.
Coming up.
So we found that people overall really liked Buchaneri, and second place was Lactobacillus casei, followed by Plantarum.
I'm John Bryce, and you're listening to the Master Brewers Podcast from the Master Brewers Association of the Americas. Here's what's coming up on the Master Brewers calendar. Don't miss the Draft Beer Basics and How Gases Affect Beer webinar, April 23rd. District St. Paul, Minneapolis meets May 10th. Need to build a food safety program for your brewery? Not sure what's required by law? Register for the Hazard Analysis and Critical Control Points course, May 10th in Philly. District Philly meets at the New Yards Brewery the following day, May 11th. District Northwest meets in beautiful Hood River the weekend of May 18th. And District Rocky Mountain holds its technical summit in Fort Collins, May 19th. View the full calendar of events at mbaa.com for more details or to find a district meeting near you. Now back to the show. All right, let's talk about those 8 sensory attributes. What were those?
So in the past, when working on this, we dug in a little bit and we actually came up with a panel where we tested just the reactor wort on its own on a regular basis, just to see what we were looking for there, any true to type characteristics, mainly so we could see if something started to go wrong or if it got infected with another type of bacteria or yeast, we'd be able to detect that relatively quickly and then start the thing over. So from that panel, we used a lot of descriptive analysis, and some of the major characteristics that we pulled from that panel were a citrus character, so kind of like a lemony aroma and flavor. We did fruity, which can either be like an apple or a lot of times we get a lot of stone fruit character from these. Funky. We did an acetic or vinegar character. Cheesy, pukey, so usually like isovaleric, butyric. Yeah. We definitely got some of that out of some of these. General acidity or sourness. We know that there can be some astringency associated with things that are relatively acidic, and then just a clean lactic character as well.
Okay. Tell us about how you set up your sensory analysis for this trial. How many panelists did you have? Were they trained? What else were they scoring for? That sort of thing.
Here at Bells, we do a lot of sensory work, and we have what we call our core panelists. So these are people who have undergone some rudimentary sensory training on, common compounds and off flavors found in beer. So we utilize that resource as well as the panel that I just talked about previously that was tasting a lot of sour wort from the past. Generally, we had between 8 and 10 people. I think the maximum was 13 on there. And we didn't do any specific sensory training based on those 8 metrics that I just talked about. It was more just a general feeling. We were really looking for an overall preference score, so what people really liked or didn't like. And then kind of as an aside to that, we were looking for, just the general sensory comparison between all the different strains.
All right, walk us through your results.
Sure. So we found that people overall really liked Buchaneri, and second place was Lactobacillus casei, followed by Plantarum. And all of those bacteria scored really high on the acidity sourness, as well as the clean lactic character. And Plantarum did pretty well for a fruity character as well. The other two didn't score that high for fruity, which was kind of surprising. Rosier came in 4th, and then followed by Bulgaricus. I should mention that we kicked out Delbrueckii subspecies lactis because it had an overwhelming cheesy pukey. It's just like it was quite terrible, and we knew that it wasn't going to do very well. We knew that we weren't going to use it for this process, so we just kicked it out of the sensory panel just to spare our panelists some grief.
Makes sense. So the strain preferred by panelists had the largest differential between TA and RQ. What did that tell you?
It told me that whatever else was being produced by that, it also had really low diacetyl levels, and it had, I think it came out at like 0.64% for ABV, so pretty low. So it kind of told me whatever else was producing besides lactic acid had some favorable sensory components to it. KCI scored really high for both the RQ and TA, and that told me that it was just a nice, clean lactic producer. It wasn't kicking out a bunch of acetic acid or ethanol or CO2 or anything like that. People seem to prefer that one as well, but overall, they seem to like what Buchaneri had to offer.
All right. How about the facultative strains? Obviously, their performance was dependent on the environment that you put them into.
Correct. And so, I really recommend that people do an experiment like this on their own because the growth conditions, the substrate are really going to influence what the final character is going to be from that bacteria. I've heard a lot talking to other brewers about strains of like Brevis that don't tend to produce alcohol. I've heard from other brewers when they get their hands on Brevis, they're getting up to 2 or 3%, which could add significantly to your final product if that's what you're looking for. I've heard of people using Pediococcus for souring. I've heard of people who get a lot of diacetyl. I've heard of people who don't get any diacetyl from that. So, really, people doing this on their own, I think it's going to be really important to tailor it to their process and what type of wort they're using and the final character of the overall beer that they want.
From a brewery operations standpoint, wouldn't you say that working with a facultative strain is a much bigger headache?
I would, mainly because I guess you don't know the extent to which they're going to do what you want them to do.
Yeah. Okay, so how about did all this work lead to any major process changes at Bells?
It did. I forgot to mention why. One of the reasons why we started doing this was because at the time, I think this was about 3 or 4 years ago, all of the major yeast suppliers who were also supplying sourine bacteria were labeling it as Delbrueckii. Once we got our PCR equipment in here a few years ago, we decided to take a deeper look at what we were getting from these places, and we started plating out our bacteria on anaerobic SDA media. And from there, we found that we actually were using 3 different types of bacteria. So from there, we separated them out based on morphology and kind of grew them up separately just to see what we were working with. And so in terms of process, what we found was, of those 3 strains that we were using, none of them were Delbrueckii. It turns out that it's incredibly hard to get Delbrueckii in the United States. I should mention that Delbrueckii was actually kind of kicked from the experiment because although we got it in from the ATCC, which is a very large bank that holds a lot of different types of yeast and bacteria strains, we couldn't actually get it to grow. And one of the reasons for that is we thought it was such a strict anaerobe and we weren't using anaerobic conditions that we just couldn't get it to work for us at all. So that was kind of the end of the line for that one. And that we knew that we weren't going to be able to use it for our process. And then of the 3 that we separated out from that, they were Rosier, Bucanieri, and Casei. And that kind of spurred this whole thing. It's like, well, what are they doing for us? What are the contributions from each of those? Are all 3 of them necessary? Are we really only interested in one of them? And so we found out that we did like a couple of them. One of them didn't work out so well for us, so they kicked that, and essentially we ended up going with a mixed culture fermentation of 2 different bacteria for our process.
Do you ever have to worry about them getting out of proportion in the reactor?
That's a great question. So that's something that we've just started looking into recently. I think for us, the thing that we're most concerned about and that we still do on a very regular basis is sensory. So if the TA looks good, the direct lactic number looks good, and it tastes the way we want it to, then we're not terribly worried about the ratio of bacteria inside of the reactor. Okay. And the sensory component does seem to stay consistent over a relatively long period of time. And so, it's not something that's concerned us very much, but it is something that we've started to look into with our new microbiologist in the past couple months.
That was Tim Lozen, winner of Best Poster People's Choice during the 2017 Master Brewers Conference. Tim's poster is available for download as part of the conference proceedings, which can be purchased from the store tab at mbaa.com. Are you running trials at your brewery? Of course you are. Why not put together a poster like Tim did for the next conference? 130 years ago, Master Brewers was built on the concept of brewers helping each other out so we could all make the best possible beer. That's still true to this day, and it's where a lot of the camaraderie in this industry originated. Master Brewers' award-winning Ask the Brewmasters is the best place to go for troubleshooting, where you'll find the industry's only discussion forum that's moderated for technical accuracy by a team of experts. See what everyone else is talking about at community.mbaa.com.
2 things that you should have known, and maybe 3 things that I should have mentioned.
Did you enjoy today's episode? Would you like us to keep making more? If so, there's a really simple way you can let us know. Subscribe, rate, and review the Master Brewers Podcast on iTunes, Stitcher, or wherever you get your podcasts.
Heading out to any other place. My fist full of courage, my heart full of rage. I can't get stuck, I can't be